Hello and welcome back to 7-2. I got you guys two lessons in a row, so that's pretty cool. I'm Mr. Fauser again. Um, we're now going to be looking at geometric sequences in series. That's the title of 7.2. Okay, so a little bit different, right? 7.1 was arithmetic. Here we have geometric. And let's start by writing the definition for this geometric sequence. And it's going to be similar to arithmetic, but a little bit different here. So it's going to be a set of numbers where you multiply, so I'm going to write as a multiplication as an x, or divide. So multiply or divide by a constant to get next term. Next term. And right, the main difference here between arithmetic and geometric is that in arithmetic we were adding and subtracting. Here we are now multiplying or dividing. So that is that main difference between the two now in 7.2. So our explicit form for a geometric sequence, thankfully there's only one that we really use. Okay, it's going to be a sub n equals a sub 1 multiplied by r raised to the power of n minus 1. Okay, and let's go through these and point out what we know, the elements in this explicit form. So a sub n, that's nth term value, and that's the same as it was with arithmetic. A sub 1 is just our first term, right? First term in sequence. R now is going to be common ratio, okay, instead of difference, it's now the common ratio, and that's going to be denoted R as it is in our equation, okay, and then N is still the same here as well. Number of terms in the sequence. So I do want to point out one thing, this new thing, this common ratio, right? This common ratio, and I'm going to put it in quotes here. We're going to find our common ratio by taking one term and dividing it by a previous term. So for example, I just wrote a sub 2 divided by a sub 1 gets us that common ratio. You could pick a sub 3 and a sub 2. It doesn't matter as long as it's two terms in the sequence next to each other. Okay, so that's how we're going to find R. So moving down to 1, the instructions say find the common ratio, the explicit formula, and the term named in the problem. So we're going to be boxing three things, right? Because we have one thing, two thing, three thing here to box for our answer. So the first thing I'm going to do is get that common ratio, right? Now, what I just said above, right, is we're going to take one term and divide it by the previous term. So I'm going to take, for example, a sub 2 and a sub 1. Negative 10 divided by 2 gets me negative 5. Okay, so my R is negative 5. Can that be true for a sub 3 divided by a sub 2, right? Because 50 divided by negative 10 would still get me that R equals negative 5. Okay, so I'm going to box that. That's part of my answer. Right, so now let's write this explicit formula and box that. So let's go into this a sub n, right? A sub 1, well, that's my 2, right? So let's plug in 2, parenthesis r, what we just found, so negative 5, and then n minus 1. So that would be our explicit form, and that's part of our answer as well. So I boxed it, and you should too. Okay, now we need to find a sub 9. And yes, that is a 9. Oh, okay, a sub 9. So let's write that. We're going to replace a sub n with a sub 9. And we remember from yesterday, right, we're taking that 9 and plugging it in for n. Now, as you can already see, we're going to have some crazy exponents here. So what I suggest is you have your calculator next to you, okay, because these exponents are still going to be coming up throughout this entire section, and it's going to be easy for us to take care of these exponents using our calculator. Okay, so make sure you have that next to you here. Now, so you could go ahead in your calculator and type in this entire thing. So 2 times the parentheses -5, all raised to n minus 1. Okay, but I think I'm going to write it like this and just change it to now raised to the power of 8, because 9 minus 1 is 8. And I'm going to type that into my calculator. So -5 to the 8th is negative 390,000. Negative 390,625. Sorry, I'm going back and forth between the board and my calculator. So now we have to take that number and multiply it by 2, right? Multiply by 2, and we're getting negative. I'm sorry, this is not negative, right? We're in even power, so it's going to stay positive. Give me 1 second here. The reason I'm just showing you every step here is to make sure we know what we're doing in our calculator. Maybe you're not doing these steps on your calculator, but I just want to make sure we remind ourselves of our algebra rules here. So -5 to the 8th is that 3,000. Is that 390,625. Okay, and then we have to take that and times it by 2. Keep in mind we're carrying down this a sub 9, okay, as our answer. So 2 times 390,625 is 781,250. Okay, so those would be our 3 answers for number 1. Sorry that took me a little second. Should go smoother here on out. I'm still getting used to this whole virtual learning thing, so thanks. So number 2, I'm actually going to have you try on your own. I will write the answer here for you, so if you want, pause, take a second to do number 2, and then go from there. So I'm going to switch colors here. I'm going to write R as my -3, right? I'm boxing that. We should have had, again here, a sub n equals 4 times r minus 1. That should be boxed. And then your a sub 9 value equals 26,244. And that should be boxed. So I hope you tried that one. There's your answers. Check them. Otherwise, we'll be moving down to number 3. So the instruction in number 3 and 4, given the first term and the common ratio of a geometric sequence, find the explicit formula in the term named in the problem, right? So we're finding 2 things, the explicit formula and the term, okay? And we have a sub 1 equals -1. We have our common ratio equals 4. Find this a sub 10. Now, luckily, we can write our explicit form right off the bat because we are given a sub 1 and we're given r. So our explicit form is going to be a sub n minus 1 times that r of 4 all raised to the n minus 1. Okay, and that's going to be part of our answer. Let's box it. Now we're going to use that exact explicit formula to find a sub 10, and we did the same thing in our last step of 1 and 2. Okay, so let's set that up. A sub 10 is now -1 times the 4, and then we're going to plug in that 10 for n. Now we know 10 minus 1 is 9, and if you want to go straight to that, 4 to the 9th is going to be 262,144. Okay. Well, that times -1, we're just flipping the sign. So a sub 10 is going to be -262,144. 144, and that's our answer. Pretty quick there, okay? Keep in mind, we really need this notation here. We're finding a certain term value in the sequence, so we need that a sub 10 equals our value, okay? Number 4, I'm going to let you do on your own as well, so pause the video, take a shot at it. I'm going to write the answer right now as well, though. So we have a sub n equals 4. Oops, sorry, negative 1. Negative 4, n minus 1. Okay, and then a sub 9, what we need to find, that value is going to be 65,536. Okay, so both of these things should be boxed in your answer. Hopefully you got those. If not, pause, try again. Thus far, we're plugging and chugging based on what we're given. Again, really similar to yesterday, we're just using a different explicit form based on our different sequence here of geometric. So moving down to number 5. Our instructions are given a term in geometric sequence and the common ratio, find the term named in the problem and the explicit formula. Well, from what we know from 1 through 4, we can't exactly find a term yet until we have the explicit formula. So we're actually going to be finding the explicit formula first, then finding the term. Okay, so that's the order we're going to do it here based on the given information we have. Okay, so looking at the given information, a sub 4 equals negative 16, and r, our common ratio, equals negative 2. Well, we're going to set this up with those given values. Okay, so using our explicit formula, we're going to set this up as a sub n is going to be negative 16, right, equals, now, a sub 1 we don't have, right, and that's what we're going to be solving for here in this first step before we go and find a sub 11. Okay, so negative 16 equals a sub 1 times our r that we were given, okay, and then raised to 4 minus 1. Why did I replace n with 4? Well, this exactly. A sub 4 equals negative 16. My a sub n is negative 16. And my n value is 4. Okay, so that's how that's going to be set up for us to solve for a sub 1. Once we have a sub 1, we can plug that back into the explicit formula and then solve for a sub 11. So let's do this. Solve for a sub 1. I'm going to carry down negative 16 equals a sub 1. Negative 2 raised to the third power is going to be negative 8, right? I'm going to divide by that negative 8. Again, your work may look a little different here, but all in all, just a quick, algebra step here. Calculated negative 2 to the third, got negative 8. Now I'm dividing negative 8 from a sub 1, and a sub 1 now is going to equal 2. So we have a sub 1 now. Now we can use that and plug it back in to our explicit formula. I'm going to switch colors to help us out here. So a sub n now is going to equal that 2 times our ratio and then raised to n minus 1. Now remember, we are finding a sub 11, so let's reset this up. 2 times negative 2, and then our n is now 11, right? So let's plug this into our calculator, right? Negative 2 raised to the 10th, this is really 10, okay, 10. So negative 2 raised to the 10th, and then times 2. We should be getting 2,048. And that's our answer, and this is our answer. So those two things are covered then. Again, in the instructions, they're written backwards, but we know in order to find our explicit formula, we need a sub 1 first, and that's why we got that a sub 1. Once we have that a sub 1, we can go into our explicit formula, allowing us to find that a sub 11. Okay, so number 6, this is where I would pause again and try This problem, very similar to number 5. You should have no problem getting it, but take the time to do it. So pause, and then I'm going to write the answer here for you to check. Okay, so a sub n is going to equal 2 times -3. I am going to also jot down a sub 1 just to make sure you have that first step down. Okay, it's 2, right? And then a sub 12, the indicated value that we're finding in the end, is going to be negative 354,294. So all 3 of these things are something you should have boxed in your answer. Well, not all 3. Sorry. Cut that. Only 2. We only need these 2. Okay, 1, 2, right? Those are the 2 things you need boxed in your answer. So let's move down to number 7. Looking at this sequence, right, we have our a sub 1 is 4, and we're missing our a sub 2, 3, 4, 5, and a sub 6 is 128. Now, in order to fill in these missing terms, right, we're going to have to figure out what our r is, so then we can either multiply or divide. Here, I would guess we're multiplying, right, from 4 somehow to get to 128. And this is how we're going to do that. So we're going to use our explicit form again, using our a sub 6 value. So our a sub 6 value is going to be 128, right, equals our a sub 1 value, which is right here. Okay, so 4 times r, what we're finding, and then our what term is 128, is the value of 128? Well, it's 6, so 6 minus 1, 6 is our n term there. Okay, now let's simplify this. We have 4, we still have that times r, and we know this is to the 5th. Okay, so what I'm going to do here is, I could rewrite this as 4r to the 5th, right? Okay, so now I'm going to divide the 4, I'm getting 32 on this side, and I have r to the 5th here. Now, in order to get r here, you're going to have to use your calculator. So hopefully that's still next to you. We're going to 5th root both sides, okay? And that's going to allow us to get r alone, and r equals 2. Now we know what we're multiplying by now, right? We're multiplying by 2. So from a sub 1, we're going to multiply by 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, 32. 32 times 2, 64. And we filled in that sequence there. All missing terms of that sequence. And just to check, we could take 64 times 2. Does that equal 128? You betcha it does. Okay, so we had done that one correctly. And that would be the process to fill in the missing terms, right? Find the common ratio, and then apply that to that first number. In number 8, you're going to do the exact same thing. Again, this is a time where I would pause, try this out on your own, find that r value. It's going to be 3, all right? And then the terms filled in, we have negative 12 for a2, a sub 2, negative 36 for a sub 3, negative 108 for a sub 4, and negative 324 for a sub 5. And if you want to check that, take negative 324 times 6, and you should get that negative 72, or negative 972. All right, all good. So let's flip. So we're going to do just about the exact same thing we did for arithmetic sequences to our geometric sequences. Is we're going to figure out the sum of them. So for geometric series, that's going to be, right, the sum, okay? The sum, we're adding between terms, okay? So that's why I wrote plus here in parentheses. The sum of the terms in the sequence. Okay, And of course, there's a formula or formulas that come along with that, just like we saw with arithmetic. There are two options for geometric as well here. So capital S sub n is going to equal a sub 1 times r times 1 minus r to the nth, and that's going to be over 1 minus r, okay? Or we could use, right, S sub n equals a1 minus an times r over 1 minus r, okay? Now, I will tell you, we don't really have an option to choose here. Depending on what we're given through from 9 through 16, right, is going to depend on which one we're going to use here, okay? Clearly, the second one looks like it's going to be a little easier to use, and I would agree. But depending on what we're given, right, so we have to be careful which one we use here to find the sum of the geometric series. Okay, so let's move down to number 9. I'll leave the equations visible here just in case. To evaluate this geometric series, right, for number 9, we have terms -3, -15, -75, -375 when n equals 7. Okay, remember, we're using the formulas we just jotted down. What is included in those formulas, though, that we don't have given to us in number 9? Well, I would say we don't have r. Okay, from the front side, what did we do to find that r? Well, we took one term and divided it by a previous term. So let's do that. Let's do -15 divided by -3. That's going to get us an r value of 5. Okay, so we know that our r value is 5 now. Now, looking at the equations above, which one do we have every term for? Do we have a sub 1? Yes, we do. Do we have r? Yes, we do. Do we have n? Yes, we do. So we're going to use that first formula that we wrote down. Okay, so S of n is going to equal a sub 1, which is -3, right, times 1 minus our r value, 5, raised to the n, which is 7, all over 1 minus r. Sorry, I forgot to plug in what r is here. Well, we know that's 5. Okay, sorry about that. But from here, we're simplifying. So again, we see this exponent happening here, 5 raised to the 7th power. We're going to need our calculator here. It's going to be a big number, sorry to say, but that's just how it's going to be. So we're now going to get -3 times 1 minus 5 to the 7th power. You should be getting 78,125, okay, and that's divided by -4, okay. So again, this is still S sub n. S sub n is going to equal, this whole thing typed into your calculator, right, is going to be -58,593. If I can read my own handwriting here. So that's what the sum of the geometric series would be in this one for number 9. We found r. We plugged everything we had into one of the equations that we figured out up here, right? And we figured out it was the first one we should be using, so we used that one. We did our calculator steps to get to that sum, and our sum was -58,593. Okay, so for number 10, this would be another time for you to pause, try this one. It's the exact same steps as number 9. I'm going to jot this down for you as well. Okay, I apologize. Before I write that answer for number 10, you probably caught this already. But this S sub n it's really supposed to be 7 here, 7 here, okay, 7 here for our answer. Our n is 7, right? Okay, so I missed that. Sorry about that. Hopefully you already had it in there, but do change that because our n is 7. That's the number of terms in this series. So make sure that's adjusted. Number 10, our answer for a sub 7, right, is 10,000, negative 10,922. Okay, so hopefully you got that answer after you paused and tried. So let's move on to number 11. Looking at number 11, right, as I said before, depending on what we're given, that's going to determine which of these formulas up here that we use. Okay, so I slid this up so we can see both of them. Right, I'm given a sub 1, I'm given a sub n, I'm given r. Now, which of these formulas has all three of those? Well, it's going to be that second one, right? So a sub 1 we have, a sub n we have, and r we have, right? On the top and bottom. So we're going to use that second equation, and let's set that up, right? So s sub n is going to equal a sub 1, which is 2, minus our a sub n, so 8,192, times our r value, which is negative 4, all over 1 minus our r value, which is negative 4. Okay, so typing this into our calculator, just simplifying, you're going to get, at some point, 32,770 on top, and you're going to get 5 on bottom. Okay, if we divide those, our final answer is going to be, sum of the geometric series is going to be negative 2,186. That's going to be our answer. So that one was pretty fast and short. Make sure you got all these positive and negatives correct here, because we're going to be multiplying these two things in the parentheses, and that's going to yield us a negative, but we have two negatives, so you're going to end up adding 2 plus to that value, and then same for the bottom, we have two negatives, and we're going to be adding 1 plus 4, and that gets us that 5. Okay, so make sure all that's straight when you're typing into your calculator. So 12, I suggest you pause. You're going to be using that second formula again for this one, based on what you're given. So pause here, try that, and I'm going to write your answer here in just a sec. So your sum is going to be s sub n, and that answer is 2,046. So hopefully you got that. That's your answer for that one. And then we're going to move on to 13. So for 13, we're given a sub 1 equals 4. We're given a sub 9 equals this horrendous number, 262,144. And then we're given the common ratio of r equals 4. So here, we're going to be using which formula based on what we're given? Well, just by looking at those two formulas, per se, we're not just given, right, a sub 9 here in the formula, but down at 13, right, we have a sub 9 equals this big number. Now, what we're going to do here, though, is find the sum of this series of all the terms a sub 1 through a sub 9, okay? So a sub 1 plus a sub 2 plus a sub 3 all the way to plus a sub 9, right? And to do that, this is how we're going to set it up. We're going to be using the second equation, okay? But since we're finding the sum of all 9 of those terms, we're going to denote our equation as capital S sub 9, okay? And n being, a sub n being that value 262,144. So let's plug everything we know right? S sub 9 equals A sub 1, which is 4, minus this huge number, 262,144, times our R, which is 4, and that's all over 1 minus our R, or 1 minus 4. Okay, so again, this is a lot more calculator work here. What you're going to be getting here on the top, if you do it correctly, is negative 100, oh geez, 1,104,872. Okay, so 1,048,572 over 5. Okay, and that value is going to get you, okay, so S sub 9 is going to get you 349,524. So 349,524. So that's the sum of all the terms from A sub 1 to A sub 9, right? All those terms in that series from A sub 1 to A sub 9, those values all summed up. So in number 14, again, I'm going to have you try it, pause it here, use that same formula we used in number 13, okay, but again, we're going to be setting it up, I'll use a different color, we're going to be setting it up as S sub 8, okay, and then we're plugging in that value for A sub n as negative 256. Okay, so pause here and do that. The answer for sub, the sum of sequence up to term 8 is negative 170. So hopefully you got that answer. Okay. So let's move down to 15. Again, we have to determine what we're given here, and then determine, based on that, what formula we're going to be using. So we're given A sub 1 equals negative 2, we're given R equals 3, and we're given N equals 7. So sliding back up here, well, it looks like that we're going to be using now this first equation, right? Because we're given A sub 1, we're given R, and we're given N. So this is pretty similar to 9 and 10, but instead of just writing out the series, they just gave us the values to plug in. So let's use that first formula and plug in. Keep in mind, sorry, I'm going to switch colors. N is 7, so we're finding the sum up to that 7th term in the series. Okay, so capital S sub 7 is going to equal negative 2 times 1 minus 3 to the 7th all over, you know what, I think, yep, so the way we wrote it in our notes above, it's actually going to be negative 2 up in the numerator with this 1 minus 3 to the 7th, sorry about that, and then all over 1 minus 3. Okay, so that's the way we wrote it. I want to make sure we write it that way down here in number 15 as well. So again, this is a bunch of calculator moves. Okay, we're going to do 3 to the 7th and then 1 minus that. So to simplify that, I'm just going to write negative 2 times 1 minus, you should be getting 2,187 here, okay, and then minus, or divided by negative 2, okay, and that in your calculator should get you negative 2,186. If not, make sure you're checking positive and negatives here, right? This numerator, what's inside the parentheses here, is going to get you a negative value. So a negative times a negative on top, right? Negative multiplied by another negative, it's going to get you a positive on top divided by a negative, gets you a negative in your answer. So make sure that's all straight. 16, again, pause here, try it. It's just like number 15. We're using that first formula because of our given. And remember, we're going to set it up as S sub 8 here because N equals 8. Our answer here is negative 335,923. Hopefully you got that. So moving down to sigma notation, again, this is really similar to yesterday's arithmetic series sigma notation as well. So we're going to be using this Greek letter of sigma. We're going to be writing our index or our first term again. So that's going to be k, and that's going to be k. That can represent any integer, right? Here's my index, starting value. Here's my n term value, okay? K being any integer, remember. And then we're going to write our explicit form here. So from the flip side, remember, it was a sub 1 times r raised to the n minus 1. And that would be our explicit form. And we wrote that on the front side of these notes. So moving down, rewriting each series using sigma notation 17 through 20. Let's do that now. Pretty straightforward, but let's make sure we got this straight. Okay, so, well, how many terms do we have in this series? We have 1, 2, 3, 4, 5. Okay, so our index is going to start at 1, n equals 1. And our n term is 5, okay? Now, this is where it gets a little interesting, right? Our a sub 1 is going to be that first term in our series, right? So a sub 1 equals 20, okay? Our r, what are we multiplying by to get to the next term? Well, remember, we did that by taking one term and dividing it by the previous. Well, 40 divided by 20 is 2. Okay, so our r is going to be 2. And then to finish it out, we just have this n minus 1. Okay, so that would be our sigma notation for this geometric series here. Now, I actually want to go down to 19 instead of going over to 18, just because 19 is another geometric series. 18 and 20 are actually arithmetic. So let's do 19 quick here. Let's set it up. We have 1, 2, 3, 4, 5 again. So n equals 1 for our index, and our n term is 5. Okay. Now, remember, we can take one term and divide it by the previous to get our r, so that's going to be 4. Right. Our a sub 1 is 16. Our r is 4, and then we finish it out by raising that to the n minus 1 power. Okay, so that would be our sigma notation for number 19. Moving to 18, honestly, I would do these on your own quick. I'm not going to explain them further than just writing the notation in sigma form, or the series in sigma notation form. But it is going to be n equals 1, 3, and then 3n plus 13. And then number 20, we have 1, 2, 3, 4, 5, 6. Okay, so 6 is our n term, and then that's going to be 20n plus 5. And those are both from yesterday. So hopefully you remember what we did from yesterday to do that. Both of these are arithmetic. So I'm going to write that just to let remind you guys that 18 and 20 are arithmetic. But that's it for today for 7-2. This is a lot of fun. I mean, it's different, obviously, this virtual learning thing, but I hope it's going okay. I hope the notes have been clear thus far through 7.1 and 7.2. It's really a lot of plug and chug, right? What are we given? What do we need to find? Which formula am I going to use? And then just doing a variety of those types of problems, to either evaluate for the indicated term, or find the explicit form of the series. So that's all for today for 7.2. Hopefully it was good. Hopefully I'll see you in the future for a later lesson. But this is pretty fun, so I hope you guys are enjoying it. Thanks.